Good day, engineers! This is Fieldwork number 2, taping over level and unlevel ground. Introduction. The common method in measuring the distance is by direct measurement with a tape. The distance measured with a steel tape is much more precise than the distance obtained by pacing. In this fieldwork report, the surveyor will learn several techniques and principles as well as some considerations to be made when taping a level ground and an even ground. The objectives of this fieldwork are to develop the skills of taping the distance on a level ground where the tape is fully supported by the ground. Another one is to acquire the skills of taping the distance on an even ground where the tape is only supported at the ends. For this fieldwork to be accomplished, the materials needed are 2 pieces of range poles, 1 piece of measuring tape, pebbles, marking pins or chalks. Now, let's begin. For part A, taping over smooth, level ground. Step 1. Assign accessible and unobstructed course to be measured by the surveyor on a level ground. Step number 2. Mark the endpoints by a chalk if it is on the pavement or by a marking pin if it is on the soft ground, and designate it as endpoints A and B. Step number 3. Use the range poles to keep the complete taping process aligned and straightened. The tape is stretched out on the ground on the straight path along A to B where the zero end is held ahead. The rear tape man is responsible for giving the signal to the front tape man if his path is straight, while the front tape man is responsible to pull the tape taut once the tape is aligned already. The front tape man gets a pin and sticks it vertically in the ground, exactly opposite the 0-meter mark of the tape. Rear tape man holds 1 pin and the rest of the pins are held by front tape man. Both the front and the rear tape man lift simultaneously the tape and move forward along the line AB to measure the next tape length. By now, the rear tape man holds 1 marking pin which signifies 1 tape length. The previous procedures are repeated to complete the next tape length measurement. Repeat the same process until all the pins being held by the front tape man have been used, which signifies 1 tally. Take note that 1 tally is equal to 10 tape lengths. After a tally has been accomplished, the rear tape man returns all the 10 pins to the front tape man to proceed in measuring the length of the course. Take note that the number of pebbles is equal to the number of tallies, and the number of pins is equal to the number of additional tape lengths. Now, as you can see, this is the table that the surveyor needs to field with data to accomplish the fieldwork. Take note that the number of small pebbles in the rear tape man's pocket now indicates the number of tallies made, and the number of pins in his possessions indicates the number of additional tape lengths. Now, let's proceed to the calculations of data. To compute for the total distance, first, get the total number of full tape lengths, and then add the partial tape length to the product of the length of 1 full tape length and total number of full tape lengths. Next, to compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. Lastly, to get the relative precision, determine the probable error of the mean, then divide by mean distance, and reduce the numerator to unity to determine the relative precision.
For part B, taping over uneven ground. The same course is measured, but this time, the tape will be unsupported by the ground and must be held an eye-level distance above the ground. Both the rear and the front tape man hold the plumb line over the center of the hub. The front tape man must hold his plumb line an arm length away from his body for the rear tape man to clearly see if it is aligned in the range pole at B. Once the rear tape man approves the alignment, the front tape man holding the O mark pulls the tape taut and drops plumb bob on the ground. This will mark the ground with a dent to guide the front tape man where he must place his marking pin. This is to be done continuously until point D is reached. Note that the partial length must also be measured as in Procedure A. The course is measured back and forth to complete the number of trials required by the professor. Now, tabulate the data in Table 2.2, taping over uneven ground. To compute for the total distance, first, get the total number of full tape lengths using the formula tally times 10 plus pins. Then, add the partial tape length to the product of the length of one full tape length and total number of full tape lengths. Next, to compute for the mean distance, determine the sum of total distance, then divide the sum by the number of trials. To get the relative precision, first, determine the probable error of the mean using the formula square root of summation of total distance minus mean distance squared all over n quantity n minus 1. Finally, divide by mean distance and reduce the numerator to unity to determine the relative precision.